Alright, today we get to decide what the hell we're going to do over here and quit screwing around. You're mixing me up there, boss. I don't want that junk head. Alright, we got the head we're working on. We got a factory racing head with unknown modifications done to it. And then we got my racing head, which I know has been modified because I've made it several times over. So this is the latest design I've been screwing with. So these are all the other ones. So how come yours is going the wrong direction? See how far your exhaust valve's over that way compared to all these other heads? That's why 45s have low compression. The valve's way over there. Alright, so this is what the factory did on their step. And that's what I decided to do on my step. I was building more compression because I filled that all in, which theoretically does hurt flow, but it gains compression so it goes faster. At least that's the theory. That has yet to been proven yet on that bike. Let's see, so it looks like this has a lot lower compression than yours. See how big it is?
Mm-hmm.
So there's your exhaust. See the difference?
Yeah.
See, mine's bigger. See, I have a bigger valve than you run. Okay, the intake. Look at the difference on the intake.
Yeah.
Whoop. That's a little compression increase there. And then me, mine's big too. You know why mine's big? Because I have bigger valves than you again. My valve's 100 thou bigger there, and it's I forget how much bigger that one is. That's it's either 50 or 75 bigger, I forget. Alright, so this one's huge. Humongous, with real low compression. Which means it doesn't run very good. I know this is not stock, because the stock one's all undercut. It's like this shape, cup shaped. So this head is not stock. I thought I had another one laying around that was stock, but is there anything over in the junk pile over there that looks like racing parts? Those are street heads, I recall. Yeah, those are stockers. See, this is what we started out with. Before and after. Look at that. Quite a cycle of engineering changes there. Huh?
Yeah.
How much bigger are we than you here? About the same.
But the valve wasn't that size.
The valve's a hell of a lot bigger than what it was before. This one gets tighter around here because that black mark is the same cut that we have here. There's my red mark.
Yeah.
So the intake's almost identical, even though we put a valve that's 175 bigger or something. 3/16. And the exhaust, look how much bigger we are. Look at the change on that.
Yeah.
So that really increases compression. Of course, we did cut deeper. Maybe. We don't know because we didn't measure it. I don't think we were cutting deeper. We're higher. Look at that.
Yeah.
So this is deeper, bigger, and smaller motor. Now we got to figure out how much we're going to cut this shelf back. Obviously they cut theirs back a long way. So we got to determine how much we're going to cut this back. So we got to figure out what our bores are here. This one here obviously looks pretty big. You just got carried away on cutting this thing. So you go basically about the center of the bore. Kind of what we're guessing the center of the bore is. Yeah, it's pretty close to what mine is. So a few thou less. Okay, so that's basically the dimension I have. And compared to you, that's basically the head gasket thickness on both of these. Okay, so we got reference line. We can come off these black mark, red mark, and cut.
Mm-hmm.
This one here, a little bit bigger, but close enough to come off of that too. So there you go. So I give this references to go by. You have to figure out how far you're going to cut this back and how much. So initially mine is about 1950. They're 800 in the center. 150 less than mine, or more I mean. So that really drops it, because this thing's really, really low compression motor. Okay, so you're at 230 right now. So we got to move that back a little bit. So if we come back to 950, same as mine, somewhere in that general area about there is where we're at. Over here, you're under 1.5 inches. So they cut way held back. So your stock cuts way back in here. Somewhere back in that area. That's how far they cut this one back.
Yeah.
That's why it's really, really a low compression motor. So if we're worried about making this stuff too big, we're already smaller than this thing everywhere. So we're doing pretty good. We have a lot more compression. We're only going to be about 8 to 1 or better probably on this motor. So, okay, so this one here, now you got kind of judgment call, some other dimensions to come from. So if we come off the center of the bolt hole here to about the edge of the shelf, roughly around 225. Mine is roughly 2.5. So I'm a 1/4 inch higher up than they are.
Mm-hmm.
So if you come over here, we don't have that same hole to come from. So we can come from our circle. I'm not sure how we're going to measure that. See, we're different. It's a different chamber design. I don't think we can come that way. All we can do is go some kind of a reference angle mark. We're going to have to just eyeball it. So looking at the valve, we're almost centered. See, you're way over there. That doesn't work either. See, nothing references off the same thing. Okay, so we know the valve angle is sort of parallel to the bore on a flathead.
Yeah, it seems to, that shelf seems to be the same.
Yeah, on a 45 it's different though.
Oh yeah, centers are different.
Yeah. So you gotta come up with some kind of an idea of what you can come off of. Well, if I come off the edge of the center of the valve, and I go to the center of the chamber, make a line. Wrong one. Where's center at? Between the valves, you'd think it would be centered, right?
Mm-hmm.
Alright, this pin ain't working with the squat. That's why I brought it with me, because I know it's a good one. New one. At least new to this job. Okay, we're going to guess the center of the piston's about in this area. So if you go down the center of your port, center and center, so things kind of line up a little bit. It's the only reference we got to go by, because these chambers are totally different from each other. Okay, so we're going to center. Okay, we're already off a different number. Center of the piston's probably about here. Oh, I know I can do it. Dumbass. I hate this scale. Okay, what's our bore size? 2.8 inches roughly. Here's our undercut. A little bit under that, but close. What's half 2.8?
Usually 1.4, but.
Yeah, about 1.4. So you go 1.4 this way.
Mm-hmm.
Okay, that's our center point. So if I come off the tangent and my center of my valve at that angle, draw us a line. That gives me at least some kind of a reference to go by. Okay, this one's 2.8 on the outside edge. That's pretty well centered, that dot. That's right here, there though. 1.4 is right here. Okay, that's our center point. So if we do the same kind of an angle, center of the valve, which is probably about in this circle area here, and here. See, our case, that's almost the same valve angle, but see on this one it undercuts a lot. Camera. See how this one's different? Because the way the chamber's design changes. See, this bolt is not, this bolt here is in a different location than what this one is. Alright, so that is our tangent line that way. Now if we do the same thing off the exhaust side, let's see, center of valve is here to here. Okay, so I do just a V angle. Line we're a little bit off on. Okay. I'm not sure exactly what this is giving me. Right now it ain't giving me nothing. All it does is give me some tangent lines coming off the pocket, so we're getting right now, but that's a start. We're going to at least cut that away to that amount, the head. That's our minimum cut we're going to do. This motor over here, right, 1.4 is right here. They're not even close. that's their line. Okay, so what are we going to do here? We got to figure out how we're going to do this.
Well, I was trying to get this lined up with this.
Yeah, but your valves are over here.
Yeah.
That's the difference in chamber size between a K and a 45. See, everything's moved closer. That's why they had a higher compression motor, ran better. The thing is, how am I going to duplicate that over to anything over here? Trying to just get some kind of referencing to guesstimate from. Let's see this one. Actually, that doesn't work too bad, to be honest. We center up the chamber as much as we can. Okay, let go. Okay, so that gives me a pretty good reference point. So we're bottom of this hole, top of that hole. Bottom, top. That gives me something to go by. There you go. That actually worked out pretty good. I think that's how we did it, wasn't it?
Yep. Bottom to
Yeah.
the top.
Yeah, bottom, top, straight line.
Mm-hmm.
Bottom, top. Bottom, top. So that's where mine's cut away. We might be filling a little bit of that in.
We're going to do that cut for
No,
the piston. It's just,
not unless we have to.
yeah, it's just flat.
Yeah, yours is flat.
Okay.
Unless we have to, we might have to. It depends. The final mock-up will tell me the piston clearance. Okay, so the... Alright, well that gives me a good angle where that's at. And then this one over here is obviously completely different than anything else. So this one here... Come off the bottom of that hole. Looks like I'm about in the middle of these two holes, kind of. See, I cut mine through here.
Mm-hmm.
I filled that in.
Yep.
See, they're about the thickness of this down. They're way down here. Like I said, I used to run it like that too. It revved up higher, but it didn't have any balls going on the track. No, like compression didn't run.
So will this get cut like this?
No, this all gets cut out.
Back here too?
This here gets cut down to here.
Oh.
We just have to figure out why we want to make it. You can see how this width here, they came in this way.
Mm-hmm.
My width here, you can see I kept it all tight because I was trying to gain compression as much as possible. So we don't want to blow this whole thing away, but we got to get some flow. We have to get a certain amount of dimension down here for flow to make it run. Now, minimum, we got to cut out everything that you see here. That has to come out, minimum. But I don't know what that's going to look like on the cylinder until we put it on the cylinder and look at it. I think we're going to have to do something more than what I got cut right here. Now, our biggest problem right now is we're leaning toward exhaust a lot. We want the intake to flow, not the exhaust. So this is kind of like the opposite angles. So this here is going to cut straight out like that. Okay, where's your cylinder? Where do you hide them at? Under all this junk where I can't see them. rear one. We already got a big problem. We cut this thing wrong. See what our gasket's going to do. Should have cut it the other way. We got this cut our gasket away now. See how the bore's way over?
Mm-hmm.
We rotate it toward the intake. We cut everything, so now our gasket's not going to fit. Have to trim the gasket away. Should have went the other direction when we did that. Oh well. Alright, so you see the flow area we got? We ain't got much flow area. Where's the red one at? There you go. Yeah. Need a foot longer, good pencil to get in there. Damn, it's hard to get in there. Can't even tell what I'm doing. Ah, that hurts. It's not helping.
And tape it to a file, or
Yeah, do something. Way back.